This webcast shows how models can be used while debugging the application functionality. In domain-specific modeling, a large portion of the code is generated from the models and then executed. Time to time there is also need to debug the application functionality. And of course, we can debug it always at the code level, but we can also go to the model level as well. In this webcast we will look model level debugging in more detail using a demonstration. Before looking at the demonstration, let's look first three kind of major debugging needs we have. The first comes from plain coding errors, typos, missing references, and things like that. Well, if we generate the code, these kind of errors don't anymore happen. Then we may also have errors in the model level, in the problem domain level. However, with the domain-specific modeling language, so with the language that already acknowledge our domain rules, it should already prevent or at least report on errors in the model level, like inconsistencies or incompleteness of the designs. Of course, then errors can be also related to the validation, so the application is not doing what was intended to do. Let's look these kind of debugging needs with Visual Studio extension of MetaEdit Plus. So I have here my application code, a small digital wristwatch function. I always can of course use the debugging functionalities of breakpoints and things like that of the IDE, but I'm also now using here the models for that. So through Visual Studio I'm accessing the models by using MetaEdit extension in Visual Studio. So if I double click here the stopwatch application, I can open the stopwatch model. And here I'm using now the domain specific language. So the concepts here in the toolbar are watch specific. And this language, because it's a domain specific, it also knows what kind of rules the domain has. So if I make something illegal kind of models, it knows that I shouldn't be able to do that. If I would be using here plain UML, UML doesn't know anything about this problem domain, so it allows me to also make illegal designs. Or if I would using, say, plain C code, for instance, again the C wouldn't know anything about the problem domain, so I would easily make errors here. There are also possibility to run checkings for my models. So, for example, I can run a checking to see that what lap time, for example, doesn't have any connections. But if I update my model, run a checking again, then at least that kind of error has disappeared. So what I have now made here is a sample model. We can try it out whether this works. And I'm now using here the auto-build code generator from Visual Studio. So it integrates my code into the Visual Studio build process, and then I can run it here. So I'm now choosing here the ACE model, and now the ACE application starts to work. And now I can go to my stopwatch application we just recently updated. So if I now press the up button, it triggers the transition and puts the icon on and counts the time. Icon is on and we count the time. But now if I press the down button, now we reach the lap time functionality like we added. But of course now we can also see that there's no way for us to get out of the down button, get out of the lap time function. So we should add here functionality that specifies to the model that if I press the down button again, then we can go to the running mode. And the next thing we could do, we could try this out whether this would work now. So I run the auto build code generation, and now the ACE model, and now we can try out the stopwatch application again. And go back to the lap time function by pressing the down button. And now if we press the down button, we go back to the lap time again. So flexible and open tools allow to combine models and code and debug them. So we can not only use IDE functionality for debugging, but also models for doing that. Thank you for watching this video. Happy debugging!